the decreasing order of the reaction rate of HBr with the following alcohols is it the following alcohols are what? Benzyl alcohol, one is C6H5CH2OH, this is the one. Then PNO2, that is para-nitro-benzyl alcohol, this is the para-nitro, and then CH2OH. So this is the second one where the nitro group is attached in the para position, and the third one when we see para-methoxy, this CH2OH group remains same alcohol, and this is OCH3. This is third one. And what is the fourth one we are given? The chlorine atom is substituted in the para position, and this CH2OH remains same. And what is now asked? We want the decreasing order of reaction rate of HBr with the following. So these four alcohols are allowed to react with HBr. And you know the reaction with HBr is an example of reaction of alcohol which follows the order. 3 degree alcohol undergoes the reaction faster than 2 degree alcohol, than 1 degree alcohol, than methyl alcohol. And here if we can observe the options given, the difference we find is that this is benzyl alcohol and these are also benzyl alcohol with a different substituents in the para position. This is the nitro group. It's a strong electron withdrawing group, and also minus M group. This is plus M group, and this is minus I plus M, but minus I dominates. So therefore, when the reaction of these alcohols where OH group is replaced, will go by carbocation formation. Whichever is the carbocation that forms readily, which is more stable, will undergo the reaction faster. So thereby, when we take the benzyl alcohol as the base, and when we treat with HBr, here is the reaction which OH group is replaced, that results in the first step as benzylic carbocation. So carbocation is formed. Thus, benzylic carbocation is formed as per the SN1 reaction. Now the group that is substituted in the para position, this group, if this group releases the electron pair into the ring, that is if it is plus M effective group like OCH3 methoxy group, then the delocalization is possible, such as here. And thereby the positive charge is nullified. So thus the more the delocalization, more is the stability of the carbocation formed, hence the reaction takes place faster. Then we have the chlorine atom, which is minus I plus M, but in the case of halogens, as you know, minus I dominates. Therefore the para-chloro-benzyl alcohol, in which the chlorine atom brings about the more delocalization. Then followed by the benzyl alcohol where there is no any substitution. But in the case of para-nitro-benzyl alcohol, when you look at this, increases the positive charge. Thus, the tendency for it to undergo the reaction will become less. Now let us take final one. So thus, here is the delocalization of the positive charge. Hence, the reaction takes place faster with plus M group, and hence this undergoes the reaction fastest. And then this chlorine is minus I effect. This also destabilizes the positive charge, and hence before this we get benzyl alcohol. Then the chlorine atom in the para position, and then nitro group minus I minus M. This increases the positive charge on the carbon and thereby decreases the rate of reaction. So thereby the order follows: first with methoxy group substituent, then without any substituent, then chlorine, then nitro group. So let us see the options. First with methoxy group, so we have 3. So 3 is there in all, so D is ruled out. After 3 without any group, that is 1. So 1 we have is after 3 1. After 3 1 we have B and C. So therefore A is ruled out. Then we have chlorine atom 4. 3, 1, 4 we have in C, but in B we have 2. Therefore, the answer is C.